So now that we know more about these extrema, let's talk about how to find them. Finding extrema on a closed interval. So there's really a procedure for how we do this, and I'll highlight it here. The first step is you need to find the critical numbers of f in the interval a to b. Then you need to evaluate your function f at each critical number in the interval a to b. And then you need to evaluate your function at each endpoint of the interval a to b. So evaluated at a, evaluated at b. And then finally you're going to compare all of these numbers, and the least of these values is the minimum. The greatest is the maximum. So let's look at this following example. Let's find the extrema of the function 3x to the fourth minus 4x cubed on the interval -1 to 2. So revisit our procedure. The first step is I need to find all the critical numbers, which means I need the derivative. So the derivative would be 12x cubed minus 12x squared. The derivative here is a polynomial, so it's always defined. So the only way I can get critical numbers is from setting it equal to 0 and solving. I can factor out a 12x squared out of both terms, and I get two solutions. I get x equals 0 from this part in the front, and I get x equals 1. Now you need to check and make sure that these are inside of our interval. Go back. My interval was from -1 to 2, and these are both inside of my interval. So I'm going to keep them both, and these are my critical numbers. So now I need to plug these into my original function, not the derivative, plug it into f of x here. So f of 0 is going to be 0. F of 1 will be 3 minus 4, or -1. So that was step 2 in our procedure. Step 3, I need to plug in my two endpoints of my interval. So I need to plug in -1 and 2 into my function. So if you go back and plug in -1, you'll get 3 plus 4, you'll get 7. If you plug in 2, you'll get 3 times 16 minus 4 times 8, you'll get 16. So what you're going to do is take all 4 of these values that you have and compare them. You're going to look for the smallest, that'll be your minimum, and the largest will be your maximum. So the smallest number I have is -1, so the minimum value is -1, and the maximum value is 16. So there's my answer. Now it's important to note that not all of your critical numbers give you minimums or maximums. So for example, if we look back, x equals 0 was a critical number, but x equals 0 does not give us a relative max or min. And if you looked at the graph of your function at x equals 0, you would see that there isn't a minimum or a maximum there.